Okay, moving forward with AI for climate mitigation. The second chapter is on introduction to climate change, which is important, but we have covered it in a great details elsewhere. So for this series of podcasts on this report, I'll just keep it very brief. Basically, we know that we are dealing with increasing greenhouse gases because of human activities, more specifically fossil fuel burning since industrial revolution. Sun's energy comes in and the thermal energy that has to go out is trapped by the greenhouse gases, which is a good thing. Greenhouse effect has allowed us to evolve ourselves as well as all the life forms on Earth, keep water in all its forms, liquid, frozen, and water vapor, and so on. But too much of a good thing when we increase greenhouse gases, because we begin to trap more and more thermal energy. So we begin to increase the temperatures, and then evaporation increases, humidity increases, extreme rainfall, storms, sea level rise, glacier melt, all these bad things begin to happen. And it's been a problem we are trying to solve now under the United Nations Framework Convention on Climate Change for a while. So we have to track emissions for this purpose, and we have a lot of good data in what we call paleoclimate proxies for temperature and past CO2s and so on. So using the air bubbles trapped in ice cores, which can grow to several kilometers over land like Antarctica and Greenland, and we have gone back 800,000 years using this approach, and even much further back to tens of millions and hundreds of millions of years in the back, using sparse data and models and so on and so forth. So this is a beautiful data that is looked at by many suddenly I got dry throat. Many papers and so on. I have detailed discussions on this from a climate science perspective. It's beautiful time series showing CO2 in parts per million going back to 800,000 years on this scale. This is the modern time, so we're going back in time, or you're going forward in time this way. So ice core data, and then we are adding modern data here at the end. And you can see that we have rapid increases and slow decreases, rapid increases, slow decreases. So we melt the ice, the ice age becomes diminished, like we are now in a warmer ice age period with glaciers on mountains, Greenland, Antarctica, and so on. But when you have a full glaciation, then you have glaciers coming all the way down Europe, North America, and getting colder and colder everywhere, dustier, and sea level drops because you lock up the evaporated water as glacier on land and so on. So it is highly correlated with orbital forcings, obliquity, precession, and ellipticity, and temperature changes begin the melting or the building of glaciers, and then we get increases in CO2 and positive feedback. Let me go and get some water. Okay, pause. So I don't know whether it's my allergy that is still not going away or just dry weather. Mumbai is a very humid place, but now the monsoon is gone. Cold weather has cooler weather has set in, and it's drier. Hopefully some water will help. There, I feel better already. Okay, so there are lots of details in this nice plot, and what you want to focus on is how rapidly we have increased CO2 in the modern times, that we have gone beyond anything we have seen for millions of years. So for millennia, atmospheric CO2 had never been above this line, and we are obviously warming because of that. So quickly then, what is the climate change chapter covering in this book? Atmospheric concentrations of heat-trapping gases are now higher than at any time in human history. This is changing Earth's climate. July 2023 was the hottest month ever recorded. in instrumental records, but people have extended back with these kind of ice core records and so on. The 9 warmest years ever recorded have been the last 9 years. Severe storms, droughts, floods, and wildfires, all made more likely by global warming, have caused extraordinary damage in recent years. Sea level rise threatens coastal cities around the world. The Paris Agreement, adopted by over 190 nations in 2015, calls for holding the global average temperature increase to well below 2 degrees C above the pre-industrial levels, and pursuing efforts to limit the increase to 1.5 degrees C. So you will have to figure out whether these are really scientific targets. I've discussed this elsewhere, not so relevant here, but those are nice numbers. So good, as you know, the lower the warming we keep stick to, the better it is, right? The world is not on a path to achieve these goals. Policies currently in place would result in a global average temperature increase of roughly 3 degrees C by 2100, and many of these policies are not fully implemented. So ideally, if we implemented all the policies we have now, we would still cross 3 degrees C, but they are not even fully being implemented. AI is making important contributions to scientific understanding of climate change. AI is improving climate model performance, providing more advanced warning of extreme weather events, and helping attribute extreme weather events to the increase in heat trapping gases in the atmosphere. AI's contribution to climate science will grow in the years ahead. I've discussed this already in the previous podcast from other reports and papers, where we have looked at how AI is helping improve models, make direct predictions, and merge models and data, and making better predictions, faster predictions, and so on and so forth. So limitless potential there. This is another key seminal figure. Charles David Keeling started collecting data in the 1950s. Quickly it became obvious we are increasing CO2, the up and down, the photosynthesis taking off during spring and then declining during fall winter months. So you see up and down during each year, and then there is an increase happening, and this is tracked very diligently by his son Ralph Keeling right now. And the main message here is, despite all the negotiations, Paris Agreement, etc., we haven't bent the curve. We're still increasing. The key question is, when will we increase, and when will we need to stop bending this curve downward to stay within 2 degrees C or 1.5 degrees C, and how AI can help. So what are the barriers then to actually monitoring greenhouse gases? This is the topic of this chapter. The use of AI to harness satellite imagery and other data sources is one of the most promising developments for greenhouse gas emissions abatement. However, there are important barriers. So each chapter has this section of barriers, ways forward, and so on. And I'm going to skip many of these things and just pick the most salient of the points, because otherwise this will become a full course, semester-long course, which is not the purpose here, just in terms of the topic. Okay. I do have full courses for other topics, but AI for climate, I'm taking brief points from different reports. If there's a very good textbook that comes along, then maybe I'll cover it as a course as well. Okay? So barrier, lack of literacy, just people not knowing. So AI literacy limits the ability of data users to analyze greenhouse gas initiatives, integrate these data into their operations, and generate customized products and applications based on these data. So AI literacy is a handicap there. So to realize the full potential benefits of AI for greenhouse gas emissions monitoring, AI literacy must be broadly improved, including in developing economies. And a nice figure of a cyclone with its hurricane with its circulation. Barriers also include conflicting AI-enabled greenhouse gas emissions data. So with the proliferation of Earth observation satellites being launched in the near future and new startup companies competing in the AI for climate space, different providers could potentially release conflicting measurements. This could undermine public confidence in the accuracy of AI-enabled greenhouse gas emissions data. This challenge could emerge with respect to methane emissions in particular, in the years ahead, the Environmental Defense Fund plans to launch methane sat, and there are other satellites that I won't go into. So the proliferation of methane tracking sources could lead to real or apparent data inconsistencies requiring integration and harmonization. Essentially, unlike CO2, which is a well-mixed inert gas that lasts for a long time, you can measure it at 1 or 2 points to get a hemispheric average very easily. Methane, is a very local thing, has only residence time of 10 years and very non-uniformly distributed because it's not well mixed, and it gets oxidized easily as well, and so on. So not all data can be measured as easily and ensured in terms of quality control and harmonization, integration, etc. And N2O creates even bigger problems in this sense. Okay, sovereignty concerns data. We talk about open source data, but who owns it, and how do we make sure that the data is used for benefiting all, and contributors also benefit, and it's not misused, and privacy concerns, all kinds of issues can come from that side. Uncertain financial models. The tension exists in the current development of AI tools for greenhouse gas emissions data. The technological innovations behind these new tools are developed by private sector enterprises that must generate revenue from the sale of the data to recoup their investment and fund further research and development. So this is the mode of operation. We cannot do anything else unless somebody just pays for everybody to collect data. However, the data must be as widely shared as possible and ideally made available to the public in open access to facilitate global acceptance of the accuracy. Protecting the intellectual property in many AI-enabled data technologies is essential to the financial success of these private sector enterprises and thus to innovation in AI data technologies, but may limit public acceptance of GHG emissions data. Kind of a broad concern, but you know that countries may also have incentives or motivation to hide their emissions because you have committed to Paris Agreement, you have promised to reduce your emissions, and if you are not able to keep up, can you fudge the numbers? Then is there somebody monitoring saying, hey, you are fudging your data, and so on, right? So what are the next steps? Several measures could help address the barriers described above and could promote the use of AI tools for greenhouse gas emissions monitoring. GHG emissions, I don't know whether it's easier to say greenhouse gas or GHG. Promote AI literacy. As we said, this can be a barrier, so promoting literacy obviously makes life easier. Promote mechanisms to validate AI-enabled greenhouse gas emissions data. So you have mix of data, for energy balance, tracking closely the emissions budgets, inventories, and so on. So you have many new satellites being launched, as we just said, but mechanisms to validate these vast and disparate sources of GHG data has to be very carefully done, especially if we are going to assign blame or responsibility for emissions to specific countries under the umbrella of Paris Agreement, because monitoring, verification, and reporting is going to be a critical part of that. Establish best practices or regulations for AI-enabled data. You know generally what that means. To strengthen public trust in AI-enabled GHG data and foster their use, firewalls could be built between companies in the data generation business and those selling low-carbon certification products based on these measurements. So greenwashing and fudging and corporations promising decarbonization and cheating are all under this in terms of best practices and regulations. Okay. Little bit more here. What else can I read? Data generation and certification could be decoupled so that the sale of AI-enabled GHG measurements is not conditioned on the favorability of the outcome to customers. So if customers say, I will monitor my own emissions and report it, who will verify it and who will make sure that everybody is doing it honestly and consistently at precision, accuracy, etc. So cheating is not possible. Set up one or several global owners of AI-enabled greenhouse gas emissions data. This is a good idea, but again, all the issues of sharing and being very honest come into handing over ownership. How do you set up a global body to do this when so much, oil companies, do they want to report their emissions? Will they let somebody else track it and own that data and so on? Already there are a lot of problems. Elevate AI for climate in international dialogue and negotiations. This is happening, but a first step in managing some of the issues above may be to foster international cooperation on addressing them. Climate policy hinges to a large extent on sound international policies with respect to these AI issues. For example, it's important to acknowledge and address AI for climate issues in such institutions as the UN Framework Convention on Climate Change, or the UNFCCC, the World Trade Organization, and the International Energy Agency, which runs the nuclear inspections and so on. Okay, so the summary of this chapter then, I don't know whether I should read it before or after, but either way, good information on the sources of greenhouse gas emissions is essential for responding to climate change. AI is helping to significantly improve such information by analyzing vast amounts of data from Earth observation satellites, airplanes, drones, land-based monitors, the Internet of Things, social media, and other technologies. So crowdsourcing is very common now. AI has been particularly important for improving methane emissions monitoring. AI helps to process data from the methane sensors at scale, combine input from multiple satellites to overcome each particular satellite's limitations, let's say in spatial and temporal coverage, integrate satellite information with data generated by other types of sensors to build multi-scale monitoring and reporting systems. So satellites have tendency to look at a certain scale, and they have tracks along which they measure data, but in situ observations can add and complement. AI is being used to better understand the sources of CO2 emissions as well. AI algorithms can be trained to survey the world's vegetation at high spatial resolution and to precisely measure the amount of biomass carbon sequestered in forestry and other forms of vegetation at scale and at a negligible cost. Cost is always critical for making this a sustainable effort. Barriers to using AI for emissions monitoring include lack of AI literacy, conflicting data, sovereignty concerns, and uncertain financial models for providing AI-enabled GHG emissions data. Just re-emphasizing. Measures to help address these barriers include promoting AI literacy, establishing best practices and mechanisms to validate AI-enabled GHG emissions data, setting up one or more global owners of AI-enabled GHG emissions data, and elevating AI for climate in international dialogue and negotiations. Should we read some more? This is for the power sector. Application of AI to help the power sector be a part of the climate mitigation effort. This is already 18 minutes, so let's leave this here and come back and do next 2 chapters in the next podcast, let's say. Okay, we'll take our time, no rush. See you in the power sector and whatever comes after that.